Good morning, everyone. I don't think I've ever done this before, but this morning I'm teaching you from a golf course through the wonders of technology. And today we are learning lesson 2.6, which is about special systems of equations. So what we've been doing up to this point with systems of equations is finding the point where the two lines cross each other when we're graphing them. And sometimes two equations actually won't ever cross each other, and in that case it's called no solution. And other times two equations may be written in different ways and still actually give you the same equation if you were to arrange them the same way. So let's take a look at a couple of the problems you might see on IXL from this lesson. First, if I have a y and no x, then my equation is a horizontal line going through that number on the y-axis. So the first equation, y equals 1, goes right here, and y equals -7 will go through the y-axis at -7. So I'm going to look at my options. These two lines look like they're parallel, so that would mean that that has no solution. There is no point where those two lines cross each other. Alright, we got 1. Now, these two equations, just looking at them, they've already arranged them so that they're both exactly the same equation. And so they took it easy on us. Sometimes, once you get up higher in IXL, sometimes you'll have to either rearrange both equations so y is by itself, or you may have to use the x and y intercepts to graph. And sometimes you'll see that they're the same equation even if they don't look exactly the same. So my first one, y equals 3 over 10x minus 10. My y-intercept is -10, and my slope is up 3, right 10. And second equation is exactly the same. So out of my options, that one is infinitely many solutions because the lines are the same. Okay, we have y equals 2, which is a horizontal line going through y equals 2. And then we have -5 as our y-intercept. And our slope is 10 over 3. It's upright, up 10, right 3. Now even though the point they cross might not be exactly where we can name the point easily, we still know that it's one solution, and that's all we need to know for this problem. So those are our main options that you'll come across. If I look at the two equations, one more, my y-intercept is +4, and my slope is -7 over 4, down right, down 7, right 4. And the other one, my y-intercept is -8, and my slope is -2 over 9, down 2, right 9. So again, those have one solution because they cross each other. The other type of problem you have today is you are going to look at two equations, and without graphing them, you will learn how to actually tell what kind of system you have. So looking at the chart over here, our first step is always to get y by itself. And after we've done that, we can identify the type of system. Because if the slope and the y-intercept are different, it will be one solution. If the slope is the same, but the y-intercept is different, that will be no solution, because that would give us a parallel set of lines. And if the slope and the y-intercept are both the same, that would mean infinitely many solutions. So let's start with this first one. I'm going to look at the slope first. So the slope of both equations would be the number in front of the x, and it's the same. So I know that it's either no solution or infinitely many solutions. So I'll look at my y-intercept, And since the y-intercepts are different, I know that that has no solutions because it has the same slope but different y-intercepts. Okay, this next one I'm going to look at the slopes first, and since they are different, the only one with that option is one solution. So I can just automatically say one solution. Alright, now this one has negative 9/5 and negative 9/5, so the slope is the same and the y-intercepts are also the same. So that is infinitely many solutions. Here's one more. This one has the same slope, negative 5/3 for both, but the y-intercepts are different, which would give you no solutions. Go ahead and pause the video and write out this chart so that you have a way to remember how to actually identify what kind of system you have, and then you'll have the rest of the time to work on IXL. Good luck!